Hi again, everyone. Today we're going to take a look at lesson 8.4, saturation. So the aim for today is 8.4, what is a saturated solution? We're going to skip the question of the day. I'm going to go over the homework though. The lesson is about saturation, and if we were in class, we would play this game I made up. That's not that great, to be honest. Called solubility battleship, but we'll skip that and go right to homework 13. So first, let's take a look at homework questions. So this first two, we're just using table G, the solubility curves, to figure out how many grams of different substances could be dissolved in 100 grams of water at those various temperatures. So that's just reading the graph. And I put a little squiggly because it's kind of approximate. You can't tell super specifically. For 3, we were looking at trends. So HCl, as temperature increases, you can dissolve less and less and less as you heat up the water. So that means solubility decreases as temperature increases. So that tells me it's probably a gas, because gases become less soluble in a solvent as the solvent is heated, versus solids are the opposite. They get more soluble as you heat them up. For number 7, a decrease in pressure has the greatest effect on a solution that contains a gas in a liquid. Solids are unaffected by pressure, and same with liquids. For some of the ones on the back here, number 9, describe the effect on solubility of potassium nitrate solid in the solution when the pressure increases. No effect because it's a solid. Number 10, determine the total mass of potassium nitrate solid that settles to the bottom of the beaker when the original solution is cooled to 15 degrees Celsius. So we can see up here in the description that they dissolved 90 grams of potassium nitrate. So 90 grams were added, but then it was cooled down to 15 degrees Celsius. And if you look at table G, solubility curves, at 15 degrees Celsius, it looks like about 28 grams of potassium nitrate can dissolve at that temperature. Here's just a quick look at that. So here's potassium nitrate. Here's 15 degrees Celsius. Yeah, it looks like just about 28 grams can dissolve at that temperature. So that would mean that the rest of it would just sink to the bottom of the beaker, or about 62 grams would settle to the bottom. For 11, a girl buys a soda and she can't finish it, so she puts it in the fridge. Why should she do this? Well, it's more delicious that way, and at cooler temperatures, more gas can stay dissolved in the liquid. Keep it bubbly. Otherwise, if you leave it out or let it warm up, it will go flat much more quickly. And if you have other questions, please let me know. All right, today's lesson is 8.4. What is a saturated solution? So, saturation, we're going to learn 3 terms: unsaturated, saturated, and supersaturated. So unsaturated is how you describe a solution that is currently holding less solute than the maximum that it could hold. So this solution, they took 30 grams of salt, put it in 100 grams of water, and all of it dissolved. And it's unsaturated, meaning this solution could still hold more. You could put in more and it would dissolve too. There's enough water to still fit more solute and dissolve it fully without any of it reforming and clumping back up and turning into salt again. So if we look at our solubility curve, here's sodium chloride. Let's say we're at room temperature. So they put in 30 grams of solute. Looks like we could add like 8 more grams and it would still all dissolve at this temperature. So if you think about it, this kind of gives us another word for the solubility curves. Yeah, exactly. You could call it a saturation curve. This line on here represents when it is saturated. So a saturated solution is when the solution is holding the absolute maximum amount of solute it can hold. That means if you add any more solute, it will not dissolve at that temperature anyway. It will reclump, or if it dissolves, then some of the other solute will undissolve and clump back up and turn into a solid again. Saturated solutions that are exactly at their saturation point are in something called dynamic equilibrium. Dynamic equilibrium means that at this point, some of that solute is dissolving, but the exact same amount is undissolving. So if a little bit dissolves, then a little piece over here falls out of the solution and becomes a solid again. So it's like the forward reaction of dissolving and the backwards reaction of undissolving are happening at the exact same rate. So it's in equilibrium. Okay, so just to, as an aside, and we're going to study equilibrium more after we study acids and bases. Dynamic equilibrium is when a forward and reverse reaction are happening at the same rate, so the overall amounts are constant. So say something is boiling. It's right at its boiling point. That actually means there are molecules boiling, but there are molecules condensing at the same time. And when it's right at the boiling point, those two reactions are happening at the exact same time. It's boiling just as much as it's condensing, so it's in dynamic equilibrium. If you were to heat it up above its boiling point, then more of the solution is boiling than is condensing, not in equilibrium. Or if you cooled it down, then more would be condensing than boiling, so that would also not be equilibrium. But right at the boiling point, just as many molecules are escaping to turn into gas as there are condensing, turning back into water. And we'll get more to that concept in our study of kinetics and equilibrium later. All right, so our third term is supersaturated. Now, I told you saturated was the maximum amount of solute a solution could hold, but it turns out there is a special case called supersaturated. That's when a solution can somehow be holding more solute than it normally can, or that it could at its saturation point. Now, how do you do this? You kind of have to trick the solution into becoming supersaturated. In this instance, if you have a supersaturated solution, if you add just one little speck of a solid, that will cause the solute to form crystals and precipitate out of the solution. So supersaturated solutions are quite unstable. And in this picture, we're seeing a supersaturated solution that has crashed out, meaning someone added a little speck of solute and all of the solute was dissolved. It was clear, we couldn't see it, and now it's crashed out. It's turned into one giant crystal. So this is how crystals are made. You can form a crystal very quickly, like rock candy forms pretty quickly in this way, where you boil a solution with a ton of sugar, and some are made a little more slowly, like a geode. So how do we do it? How do we get a solution to hold more solute than it normally can? Say we've got potassium nitrate. All right, say you've got it at its room temperature. So it's holding about this much solute. We'll say it's got 28 grams. Well, you want to supersaturate it. So if you heat it up to like 80 grams, how about, we'll say 60 grams, now all of a sudden, this potassium nitrate solution, you could dissolve like 105 grams and it would all dissolve, right? Because it's so hot. So now what you're going to do to make it supersaturated, because right now it's saturated, you're going to slowly, slowly cool it. Cool it. Oops, where did my arrow go? Come back, arrow. Cool it down without bumping it. And all of a sudden, you still have 105 grams dissolved, but at that temperature, that's way more solute than it normally holds. So at this point, it is now, the dot is above the line. It's now super saturated. And in class, we were going to do a lab where we did this, where we super saturate and make a crystal. And we obviously won't be able to do that, but I'm gonna see if there's a way we can do it online, or at least see a video of how this process works. Okay, so here's an example also. So we've got a beaker of water. It's got 5 grams of something that has dissolved and 95 grams sitting at the bottom. And we can see it's at 25 degrees Celsius, about room temperature. And it's still dissolving, so it's not in equilibrium or anything. These particles are still dissolving. This is unsaturated, meaning this solution can hold a lot more. A lot more of these grams can still dissolve, and it'll keep going. It'll keep holding more solute. So time passes. Now 91 grams of the solute have dissolved. Ooh. 9 grams are still just sitting at the bottom that have not dissolved yet. And you'll notice we're still at the same temperature, but now we've reached dynamic equilibrium. So, would you call this solution unsaturated, saturated, or supersaturated? Saturated. All right, now we're gonna add heat. This red triangle means add heat. So we're heating it way up to 50 degrees Celsius, and boom, everything dissolved. All of those grams that were sitting at the bottom dissolved. And in fact, you could probably add a lot more solute to this and those would dissolve too. So would you call this solution unsaturated, saturated, or supersaturated? This one's unsaturated. You could add more and it would still dissolve. Okay, now it's being slowly cooled down, slowly cooled to back to 25 degrees Celsius. But you'll notice all 100 grams of solute are still in solution, still dissolved. Nothing has precipitated out yet or fallen to the bottom. So this solution, is it unsaturated, saturated, or supersaturated? That's right, supersaturated. Okay, then maybe somebody bumped it a little bit or you just let it sit over time. Some of the solute fell back out and sank to the bottom, but it's at dynamic equilibrium now. So this solution is now saturated, just like it was before here. Saturated at 25 degrees Celsius with 91 grams dissolved. Cool. All right, so we can also try to figure out if a solution is unsaturated, saturated, or supersaturated by looking at the solubility curves. So we'll start with this example. We've got 145 grams of Ki, potassium iodide, at 20 degrees Celsius. So here's Ki. Here's 145 grams and 20 degrees Celsius. Is that unsaturated, saturated, or supersaturated? Well, it's right on the curve. That means it is saturated. How about this one? Now we've got 100 grams of potassium nitrate. That's at 50 degrees Celsius. So here's potassium nitrate. Here's 100 grams at 50 degrees Celsius. What do you think? Unsaturated, saturated, or supersaturated? That one is supersaturated because the dot here is above the line. That means the solution is holding more than it normally can at that temperature. Somebody did something to trick the solution into holding that many grams of solute. How about 20 grams of sodium chloride at 90 degrees Celsius? Here's sodium chloride. Here's the 20 grams at 90 degrees Celsius. Yes, that one is unsaturated because the dot is under the line. All right, so the next activity would be to play this solubility battleship game, but instead we'll just skip right to homework 13. Thank you guys for tuning in. Have a great rest of your day.